Alright, so this is a PowerPoint about kinetic and potential energy. We kind of talked about both of them, but we're going to make sure that you understand the differences between the two. What happened? I messed up. But we'll keep going. So we already understood from the last video, if you paid attention, that energy is never created or destroyed. It can only be stored as potential energy or transferred from one form to another in energy transformations. So here we have some batteries, and they store energy in the form of chemical energy because they're chemicals such as, what are the batteries? What's in the batteries? Nickel, cadmium, things like that. Those chemicals are in the batteries, and that gives it its stored potential energy. Then we see a moving car, and it's using a lot of energy. It transforms that gasoline, which is chemical energy, into energy of motion or kinetic energy. Food. The food we eat, of course, is chemical energy that our body gets when it breaks down those chemicals in the food and transforms that into our energy of motion. And even somebody who's sleeping, just like you and I, or this pretty little cute puppy, uses energy because all of your bodily functions require energy to work. And of course, any animal needs that energy from food to continue these functions during the sleep process. So all matter, as we know, is made up of particles or atoms, and these atoms and matter never stop moving. So these are always in motion. Alright, so the big idea here, how is energy divided? Well, energy can be potential energy, or energy can be kinetic energy. Remember that potential energy is stored energy in an object. So it's not being used until it's needed. It's stored, like the battery is storing it. But when we put the battery in something to make it work, it's changing from potential into kinetic. Potential just means the energy that's in the substance has the ability to do something for us, right? Examples of a potential energy would be a rubber band. If the rubber band's just laying there and not moving, it has stored potential energy. But when I stretch that rubber band and release it, I have changed that potential energy that's in that rubber band into kinetic. The water at the top of the waterfall, we talked about this example in the last video. When it's at the top of the waterfall, it's all stored up energy. Remember, the higher something is, the more potential energy. So when water falls over, it's changing from potential to kinetic. A yo-yo held in your hand. You hold it up. Before you release it, it has all that potential energy. And another example would be the bow and arrow. When you pull the bow or the arrow in the bow, before you release it, you have given it a lot of potential energy, and when you let it go, that one transforms to kinetic. Remember, the higher an object is, the more gravitational potential energy it has, which means that just the higher up it is, the more that gravity can pull it down ultimately. So that's why we really refer to that as gravitational potential energy. So the higher an object is, the more potential energy. The more massive an object is, it also has more potential energy. So something that's heavier will have more potential energy than something that's light. So if you look at these two examples, which one of these has the most potential energy? Well, if you say A, you are absolutely right, because the brick is way heavier than the feather, and the things that are heavier have more potential energy. So the answer was A, the brick. What about these? So it's changing the object's height can change its potential energy. So if you want to drop an apple from the top of one of these three things, where would you get the most potential energy? Well, if you said at A, the high top of the high building, that was higher than anything else. The higher something is, the greater the potential energy. So dropping an apple from this tower would definitely give it the greatest gravitational potential energy. So potential energy is converted into kinetic energy. When the stored energy begins to move, the object's transferring that potential stored energy into kinetic energy or energy of motion. So the boy's standing there with his arms and then he's running. So first he's standing there, he has potential energy, and that potential energy he's gotten from food, of course, and then he starts running, and his potential energy is being transferred into energy of motion or kinetic energy. So kinetic energy is the energy of moving objects. Kinetic, actually the word kinetic means motion or movement. And when the stored energy is being used up, it makes things move. Okay, examples of kinetic are the skier. The skier standing at the top of the hill has potential energy, but when the skier starts to ski down the slope, he's transferring all his potential energy into energy of motion, which is kinetic. The runner, before he starts running, he's standing, so he had potential energy, then he started to run, and that changed into kinetic. The motorcycle, okay, so the motorcycle's standing there with gasoline in it. That chemical potential energy is gasoline, that's stored energy in the gas. And when the guy starts to ride his motorcycle, that gasoline, that potential energy, is being transferred into energy of motion. And the guy is slipping on the ice. Well, you get it. You get the drift. So the faster the object moves, the more kinetic energy is produced. So remember, when the object's at its fastest, that's when you have the greatest kinetic energy or energy of motion. The faster it is, the greater the kinetic energy. And the greater the mass and speed of an object, so the heavier and the faster, you get more kinetic energy, So when these two objects move at the same speed, so they're moving at the same speed, which one would have more kinetic energy? Well, let's think about it. The fastest and the most massive, so which one has the greater mass? If you said the truck, you're right, because the truck has the more mass, so it's got more kinetic or energy of motion. An object has the most kinetic energy when its movement is the greatest. When an object has the least potential energy, it has the most kinetic. Remember, we said it's kind of like a seesaw. When one's high, the other one's low. So when one person's up in the air, the other one's down at the bottom on the seesaw. So this is the same scenario. When the potential energy is high, the kinetic energy is low. When the kinetic energy is high, the potential energy is low. And as if you put your two fists out like a seesaw and put one up and one down, when one goes down and the other one goes up, kind of where they meet in the middle, that's where you have kinetic and potential energy equivalent when they're in the kind of the middle. The water bottle is knocked off a desk. When does the bottle have the most kinetic energy? If you said right at the bottom of the fall, you're absolutely correct, because at the bottom of the fall, it's moving its fastest. That's where it has the most kinetic energy. Oops, we had answer choices. Well, I just gave you the answer at the bottom of the fall. So it has the most kinetic energy when its movement and speed are the greatest, which is at the bottom of the fall right before it hits the ground. When an object has the least potential, it has the most kinetic. Remember the seesaw. Okay, so when does the train on the roller coaster have the most potential energy? Well, if you know how to roller coaster works, you have like a chain link bringing the coaster up to the top. The highest, when it's at its highest, so usually the highest point of roller coaster, but not just usually, but always, the highest point of the roller coaster is that very first hill. So when does it have its greatest potential energy? When it gets to the top of the very first hill, that highest hill. So the higher the train is lifted by the motor, the more potential energy is produced. At the top of the hill, the train has a huge amount of potential energy, but very little kinetic. As the train accelerates or speeds down the hill, the potential energy is then converted into kinetic energy. There's very little potential energy at the bottom of the hill because that's where it's going its fastest, so that's when there's the greatest amount of kinetic energy. When does the train on this roller coaster have the most kinetic energy? The most kinetic. So when is it moving its fastest? When does it have the least potential? You said at the bottom of the hill, you're absolutely right, because that's when it's moving its fastest. So that makes that the activities that you will do this week. So we're not going to do this right now. Okay, so what do you need to know, and make sure that as you do your Cornell notes, you can do them with me. But a summary is all energy is divided into two types, potential and kinetic. Potential energy is the energy stored in an object. Kinetic energy is the energy of a moving object. And remember, energy is never created or destroyed. It is always